In last lecture, we have discussed about what are different types of bonds, what is the difference between a single bond and double bond, and we have seen about single bond, double bond, triple bond, here covalent bond and ionic bond. Covalent bond in the sense sharing of electrons between two atoms. Here we have seen examples of single bond in hydrogen, double bond in oxygen, and triple bond in nitrogen. And in this lecture, we are going to see what is meant by tetravalency, what is meant by catenation, isomerism, branches, chains, rings, etc. And if possible, we will try to see what is meant by hydrocarbons. Now, so first of all, while coming to carbon, carbon is so versatile element. Versatile. So what is making carbon so versatile in the sense? Two characteristics. Number one, catenation. And number two, it is tetravalency. We can call it as a tetra covalency also, or tetravalency, tetracovalency, both are correct. First, let us try to understand what is meant by catenation. Catenation is nothing but it is a property. It is a property of elements to self-link. So simply to say, if it is carbon, carbon can combine with another carbon, that can combine with another carbon. So like that, if similar elements are combining together, so if carbon is only combining with another carbon, that is combining with another carbon, like that, if same elements are combining together to form long branches or chains or something, that is known as catenation. You can observe ozone nothing but O3, where 3 oxygens will combine together. And we have another example, S8 sulfur, 8 sulfurs, that will be means 8 sulfurs will be combining together to form S8. Like that, similar elements, if it is combining together, if it is forming long chains, branches, rings, etc., that is known as catenation. And carbon, it can form very long chain. So how it can form, why it can form, in the sense, you can observe carbon, I said valency 4, 1, 2, 3, 4. It can combine with 4 different monovalent elements. Now, for example, it can combine with hydrogen, it can combine with chlorine, it can combine with not chlorine here. Yeah, chlorine, fluorine, bromine, iodine, right? Like that, it can combine with different elements. Here, instead of hydrogen, if it is combining with another carbon, let us assume, then you see this carbon will have 4 valencies, right? And again, if it is hydrogen and hydrogen here, if it is filled, here there will be 1 valency. If hydrogen is combining with the carbon, there ends the chain. If it is not, if there is no hydrogen, then if there is another carbon, again this carbon needs another 3 elements. If it is hydrogen and chlorine something, again there is 1 valency. If there is some other element, chain will stop. If it is not, again if it is carbon, that chain continues. Like that, carbon can combine with the same carbon element to form long chains. That property is known as catenation. And while coming to tetravalency, what is the tetravalency? In the name itself, we have tetra for, you see, mono. Mono means 1, di means 2, tri means 3, tetra means 4. So carbon has 4 valency. Because of carbon 4 valency, it can combine with 4 other different elements. So carbon atomic number 6, which is very near to 10, and it needs 4 electrons to get stable. It cannot, it neither loses electron nor gains electron. It can share 4 electrons, maybe from 2 different elements, or maybe from 3 different elements, maybe from 4 different elements. Yes, it can share with 2 elements, it can share with 3 elements, it can share with 4 elements. Because of the tetravalency, 4 valency, it can form long chains, long branches at the same time. It can combine with different elements, maybe similar elements, maybe different elements. You see, if needed, CH4 we will tell. So carbon can combine with 4 hydrogen, carbon dioxide, carbon can combine with 2 oxygen atoms, like that. So those are the two properties which making carbon so versatile element. Then we'll try to see isomerism. That's a new word. Isomerism. So what is meant by isomerism? If a molecular formula represents two or more structures having different properties, for example, okay, this we'll try to understand after learning about chains, branches, and rings, right? So before that, let us try to understand what is meant by allotropes. Allotropes nothing but if a same element, if it is obtaining in different forms, same element, if it is obtained in different forms. For example, carbon, because we are in chapter carbon and its compounds, no? Carbon, you can observe carbon in different forms like diamond. You can get it as graphite. You can get it as fullerenes. Fullerene simply to say C60, 60 carbons will be there. And if you observe carbon, each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure. In textbook, you can find about the carbon. And while coming to graphite, each carbon atom is bonded to 3 different carbon atoms in the same plane, given as a hexagonal array. Hexagonal structure, we can find graphite. So let me show you the textbook. So here you can observe. So first we have discussed in textbook regarding the introduction part and bonding in carbon. So what is covalent bond we have seen. We'll try to see what are those. And here carbon could gain 4 electrons, but it would be difficult for the nucleus to handle with the 6 protons, and it cannot gain electrons, it cannot lose electrons. That explanation you can find it here. Then we have seen single bond hydrogen, double bond oxygen, and triple bond nitrogen. Then allotropes. So what is allotropes? The element carbon occurs in different forms in nature, right? So here this is graphite. Graphite, where we can use that one in pencil lids, we can use that graphite. We can observe this hexagonal 1, 2, 3, 4, 5, 6, 6 sides, 6, nothing but hex. A hexagon in mathematics you can find. So if you observe, this is hexagonal arrangement of carbon atoms in graphite, so that it will be so brittle and weak. While coming to diamond, it is rigid. So this structure is rigid, and here as I said, 1 carbon atom will be bonded with 3. This is 1. You can observe here, 1 carbon atom, it will bond with 1, 2, 3 carbon atoms. But while coming to diamond, 1 carbon atom is bonded with 1, 2, 3, 4 carbon atoms. So diamond will be so rigid, and while coming to graphite, it is brittle. And not only diamond and graphite, we can get it in form of Buckminster fullerenes, that is fullerenes, where there will be 60 carbon atoms. So these all are allotropes of carbon. Only carbon element, same carbon element, but obtained in different forms, different structures. That is about allotrope. Then, so versatile nature of carbon, that's what we are talking about. Carbon, there are 2 points you can observe. First point, carbon has unique ability to form bonds with other atoms of carbon. That is nothing but catenation, right? Catenation. So self-linking of similar atoms with, self-linking of atom with similar atom. And these compounds may have long chains of carbon or branched chains of carbon, or even it is arranged in form of rings. I'll explain you what is that long chain, what is that branches and rings, etc. So if same atom is combining with, if an element is combining with same atoms, that is known as catenation. And here, second property, that is known as tetravalences, since carbon has valency Carbon has valency 4. So it can bond with other 4 elements. It has capability of bonding with other 4 elements of carbon or other monovalent. It can carbon can combine with carbon, or it can combine with monovalent such as hydrogen, chlorine, bromine, iodine, etc. So those are the 2 properties. Now we have to understand about what is meant by saturated and unsaturated carbon compounds. Before that, let us try to understand few concepts. You see guys, in 9th class we have discussed, if an element is combining with another element, we can call it as compound. One element, in general terms I am telling you, if one element is combining with another element, we can call that one as compound. For example, hydrogen is one element combining with oxygen. Hydrogen plus oxygen, it forms H2O compound or molecule, right? Nitrogen can combine with hydrogen, it can form ammonia compound. Same like that, carbon dioxide we can get, hydrochloric acid we can get, H2SO for sulfuric acid. These all are compounds. So what is meant by compound? If one element is combining with another element, we will get compound. Now you see, okay, here what I said, element plus element, which is nothing but compound. Now if one of these 2 elements is carbon and there might be some other element, no worries, maybe hydrogen, maybe oxygen, maybe nitrogen, maybe chlorine, bromine, iodine, whatever it may be the element, but this element should be carbon. One of these 2 elements should be carbon. Then that compound we are calling it as carbon compound. Carbon compound. Try to understand. If there are different elements, it is just compound. But if there is one carbon compulsory, then that is known as carbon compound. And here, if there is carbon and this element is compulsorily, if it is hydrogen, means we don't have any other elements except hydrogen and carbon, then this compound is known as hydrocarbon compound. It is quite simple and easy to understand, right? If there is 2 different elements, that is just a compound. In these 2, if one of the elements is carbon, it is carbon compound. If hydrogen is combining with carbon or combining with carbon combining with hydrogen, no, we don't want any other element, only 2 elements, hydrogen and carbon. Such type of elements, such type of compounds known as hydrocarbon compounds. Now let us try to understand more about only these hydrocarbon compounds. Hydrocarbon compounds are divided into 2 categories. Number 1, saturated hydrocarbon compounds. Number 2, unsaturated hydrocarbon compounds. There are only 2 categories, that's it. Saturated hydrocarbon compounds and unsaturated hydrocarbon compounds. We don't have supersaturated hydrocarbon compounds, nothing. Just saturated, unsaturated. Okay. What is that saturated? What is that unsaturated? Let us go to first lecture, what we have discussed. If you can observe, here I told you carbon can have 4 valency, and 4 valencies however you want you can represent. Here if you can observe this diagram, in this carbon with 4 single bonds I have represented. While coming to this diagram, carbon with 2 double bonds I have represented. While coming to this diagram, carbon with 1 triple bond and 1 double bond I have represented. So by this, what we can learn in the sense, carbon can have single bonds between carbon. Carbon can go with double bonds between carbon. Carbon can go with triple bonds between carbon. Means carbon can go with single bonds. Carbon can go with double bonds. Carbon can go with triple bond also. Now, if carbon is going with only single bonds between carbon, I mean, how many carbons you take? How many carbons in between carbons? If there are only single bonds, then such type of, I mean, only single bonds, we are calling it as saturated. And this remaining two, so carbon has double bond between that one, and the carbons, in between carbons there is triple bond, na? So that if you can find at least one double bond, at least one triple bond, that is known as unsaturated. Not all double bonds, at least one double bond, at least one triple bond, that is known as unsaturated. Now, while coming to saturated hydrocarbon compound, unsaturated hydrocarbon compound, what we can tell, if you can find only single bond, that is known as saturated hydrocarbon compound. If you find double bond and triple bond, then that is known as unsaturated hydrocarbon compounds. Now let us get into somewhat brief. Okay, first let us see hydrocarbon compound, two types, saturated and unsaturated. Single bond, double bond, triple bond. Now you see, if you find only single bond, of course many hydrocarbon compounds we can able to mention, we can name, we can draw. We'll see that single bond, double bond, how many double bonds? At least one double bond, triple bond. And you see, we can able to increase number of carbon counts also. We can increase carbon counts. If you are increasing carbon counts, we can draw hydrogens for one carbon, we can draw hydrogens for two carbons, we can mention hydrogens for three carbons. We can. When carbon count is increasing, there are few names we need to understand. I'll tell you those names, I'll tell you those root words. So first let us see single bond. Single bond where? Single bond between only carbon. Double bond, that is also only between carbon. Triple bond, that is also only between carbon, not between hydrogen and carbon, only between carbon. You have to understand that. And if you can find only single bonds between carbon, there is a functional group. That functional group name we are giving it as alkane. Try to understand, and also try to understand the pronunciation. It is alkane. That is a functional group. And there are many hydrocarbon compounds we can get with only single bonds. And if you can find a functional group with many hydrocarbon compounds with double bonds, we are calling it as alkene. First one is alkane, single bond. Second one is alkene. Third one is alkyne, where in the functional group where we can find hydrocarbon compounds with triple bond between carbon. So there are three functional groups we are talking about: alkane, alkene, alkyne. In alkane, we can find only single bond between carbon. In alkene, we can find only double bond between carbon. And in alkyne, we can find only triple bond between carbon. And we have general formula also. What is the general formula of alkane means? CnH2n plus 2. Guys, C stands for carbon, N stands for number, H stands for hydrogen, 2 is as usual numerical value 2, N stands for number, and here for alkene, CnH2n, that is a formula, and for alkyne, CnH2n minus 2. So try to understand step by step. I am telling. We have single bonds between carbon, double bond between carbon, triple bond between carbon. If you can find only single bonds, we can call it as alkane functional group. If you can find double bond, we can call it as alkene functional group. If it is triple bond, we can call it as alkyne functional group. And for alkane, we have general formula, that is CnH2n plus 2. For alkene, we have CnH2n. For alkane, we have CnH2n minus 2. Now, in place of n, we can substitute 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We can substitute numbers. Okay, if you substitute numbers, we'll get some formulas. After getting formulas, we need to name those compounds. That is the only work we have in this lecture. That's it. So we need to substitute numbers and we need to give names for that. Now, before giving names, let me give you one chart. Try to understand names. Okay. If we have only one carbon, we have to call it as meth. Just we'll try to apply it. We'll try to apply it. If possible, try to note that down in your book. If there is only one carbon, you have to pronounce that one carbon compound as meth. If you have two carbons, we have to call it as eth. Whenever in the compound, maybe alkane, alkene, alkyne, if you can find only two carbons, then we have to pronounce it as eth. If you have three carbons, it is prop, P-R-O-P, prop. If you have four carbons, name it as bute. It is not beauty, but in English, it is bute. Pronunciation should be bute, like a beauty, bute. If you have five carbons, we have to pronounce it as pent. That count. One carbon means meth, two carbons means eth, three carbons means prop, four carbons bute, five carbons pent. If you have six carbons, go with hex. Hex. So in 10th class, it is more than enough for you. No need to go with 7, 8, 9, 10. So try to go with these names. One carbon meth, two carbons eth, three carbons prop, four carbons bute, five carbons pent, six carbons hex. These are just count of carbons. Note this down. So these are the names we need to remember. And while coming to here, another thing I need to say, there are few root words for alkane, alkene, alkane. Root word for the alkane is ane. Root word for alkene is ene. Root word for alkyne is ane. Ein. Okay, now let us try to substitute numbers and let us try to give names for this. Okay, in place of n, we can substitute 1. If we can substitute 1, it becomes C1H, 2 into 1, 2, 2 plus 2, 4, C1H4. Of course, you can mention it as C1H4 or you can remove this 1 also, no worries with that. You can represent 1 or no need to represent 1. No problem with that. Okay, now if you represent 2, it becomes C2H, 2 2s 4, 4 plus 2, 6. If you substitute 3, it becomes C3H, 2 3 6, 6 plus 2, 8, H8. If you substitute 4, it is C4H, 2 into 4, 8, 8 plus 2, 10, H10. If you substitute 5, it becomes C5H, 2 into 5, 10, 10 plus 2, 12. If you substitute 6, it becomes C6H, 2 into 6, 12, 12 plus 2, 14. Right. We got, you see, how many chemical formulas we got, how many hydrocarbon compounds we got. CH4, C2H6, C3H8, C4H10, C5H12, C6H14. Now we need to give names. How to give names? It is quite simple. Here we have discussed. Here we have discussed, if we have only one carbon, we have to call it as meth. Na? So this is meth. And this is alkane. What is the root word for the alkane? It is ane. Just write ane, it becomes methane. Simple. Now this one, you see, there are two carbons. When you have two carbons, you have to call it as eth. And this is the formula what we are using, CnH2n plus 2. CnH2n plus 2 means it is alkane. Root word for the alkane is ane. It becomes ethane. Now you see three carbons. Sorry, it is not meth, eth, prop. It is prop, belongs to alkane functional group, so it is propane. This belongs to alkane and there are four carbons, it is butane. There are five carbons, belongs to alkane, it is pentane. There are 6 carbon belongs to alkane. This is known as hexane. See how simple it is. That's it. Now we need to go with alkene. But alkene, 1 is not possible because if you substitute 1, it becomes C1H2 into 1, 2 means 1 carbon with 2 hydrogens. You see guys, carbon with 4 valency. How many hydrogens they are telling? 2 hydrogens. If 2 hydrogens are mentioned, here there will be valency. Compound is not satisfied, it is not stable. So that 1 is not possible in alkene as well as in alkyne. In alkene and alkyne, 1 is not possible. You have to understand that. From 2 it is possible. Now, if you substitute 2, it becomes what? C2H 2 into 2, it is 4, C2H4. If you substitute 3, it becomes C3, 2 into 3, it is 6, H6. If you substitute 4, it becomes C4, H, 4 2s 8. If you substitute 5, C5, Cn means C5, H2 into 5, 10, that is H10. If you substitute 6, C6, H12. Now, here also we can do the same for alkyne. If you substitute 1, 1 is not possible, I said, because if you substitute 1, it becomes C1, H, 2 into 1, 2, 2 minus 2, 0. Means there should be only 1 carbon at 0 hydrogens. Is that possible? No, that compound is not stable. So 1 is not stable, 1 is not possible. Let us substitute from 2. If you substitute from 2, it becomes C2H, 2 into 2, 4, 4 minus 2. 4 minus 2 is 2. Right. Next, if you substitute 3, it becomes C3H, 2, 3, 6. 6 minus 2, 4. C4H, 2 4s 8. 8 minus 2, 6. C5H, 2 multiplied with 5, 10. 10 minus 2, 8. C6H, 12. If you substitute 12, 6, it becomes 12. 12 minus 2, 10. C6H10. Now it is easy for us to give names also. 1 is not possible, so there is no meth from eth. It is eth. And what is the root word? I said it is ene. So it is ethene. And this one is ethine. This one, 3 carbons. 3 carbons means prop. Belongs to alkene, propene. 3 carbons means prop. Belongs to alkene, it is propine. C4H8, 4 carbons with alkene. Here C4H6, 4 carbons with alkyne. It becomes butene. Here it becomes butine. Now 5 carbons with alkene. Pentene. Here it is pentine. Here we have hexane. Next hexene. Then hexine. Like that, we can write chemical formulas. We can go with the names of the carbon compounds. Here we have only hydrocarbon compounds, guys. We don't have any other. We have only hydrocarbon compounds. So it's single bond, double bond, triple bond. And in next lecture, we'll try to draw structures of these so that we can understand how we can draw single bond, how we can mention double bond, how we can mention triple bond. And in next lecture, we'll see why we are going with only 3 bonds. Why can't we go with 4 bonds? That also we'll try to understand. If possible, normally I'll tell you, see, okay, why we are going with the hydrogen single bond, and oxygen double bond, and nitrogen triple bond. Why can't we go with 4 bond? You see, in orbits we have orbitals, s orbital, p orbital, d orbital, f orbital. There are shapes for Spdif orbitals. In 9th class you have studied Spdif orbitals. S orbital will contain only 2 electrons, p go with 6 electrons, d with 10, f with 14. There are shapes. What is the shape of s orbital? Means it is spherical. Shape of p orbital, dumbbell. Shape of d orbital, double dumbbell. Shape of f orbital, it is triple dumbbell. Like this. Of course, it is not there in your CBSE 10th class NCERT textbook, but if you go to 11th class, definitely you are going to get it. Okay, now what is the highest count of electron in orbital? Means F. Now let us consider f orbital and f orbital both are combining together. F orbital, F orbital. What is the shape of F orbital? I said it is triple dumbbell. We don't have any other orbital, na? S orbital with spherical, p orbital with dumbbell, d orbital with double dumbbell, f orbital with triple dumbbell. We don't have any 4 dumbbell something. F is the last. Now consider f orbital and f orbital both are combining. You see, this is 1 dumbbell. I mean 3 dumbbells we have to draw. This is second dumbbell. This is third dumbbell with 3 dumbbells for f orbital. That is bonding with another f, na? So another f will bond like this. F also triple bond, right? Like this. Like this. Now you see, if there is any bond between side by side, there is a bond side by side, right? This bond we have to call it as sigma bond. This one is sigma bond. If you can observe bond side by, I mean walls, these are walls. This wall and this wall will bond, which is known as pi bond, and this wall will bond, which is known as pi bond. Here you can see this is pi, this is pi. Here you can observe 1 sigma bond, 2 pi bonds. Total we have 3 bonds. That's it. So side by side you can observe 1 sigma bond. Walls you can observe 2. Right here. And of course this is also same, this one, na? So that this you should not take count. This one and this one you should not take count, because this and this we are not taking count, na? Like that. So 1 sigma bond, 2 pi bonds, total will be 3 bonds. So triple bond is the highest bond where we can observe between the atoms or between the compound. In the compound we can find only triple bond. We cannot go with 4 bonds. That is the concept. And in next lecture we are going to see structures of these alkane, alkene and alkyne. That's it in this lecture.